Hello everyone, welcome to the Java course. When we use arrays, we know that the size of an array is fixed. It is possibly not so convenient if we don't ever want to use the all the spaces in the given array. So is there any other ways to allocate the memory to store things dynamically? Yes, there is a data structure called ArrayLists. The advantage of the ArrayList is like that. We can set up a variable length of the ArrayList instead of having a fixed memory allocation to a given array. It has another property. And an ArrayList is going to have a lot of memory spaces that store object references, but not pure primitives. So that means we have to create objects and then we put the objects into the ArrayLists. We will show this issue later. The default size of an ArrayList is 10 cells. So even though it is a dynamic memory data structure, the initial space given to us is 10 cells. And this size can be changed according to our actions of putting more and more objects into the ArrayList. If we really want to initialize our ArrayList to a larger amount, we can have some actual parameter to put into the ArrayList constructor. So how can we construct an ArrayList? Before doing so, we have to import the ArrayList library. Okay, in this command, we are going to import the ArrayList library. And after we have imported it, we can create our own ArrayList. Okay, what does it mean by this statement? I'm going to create an ArrayList. The reference variable of this ArrayList is called fruit. And what does the fruit mean? It is pointing to an ArrayList that stores string references, but not string objects directly. We have to remember that ArrayList stores object references, not the primitives or the objects directly. And how can we create an ArrayList in the memory space? We use the new keyword and we follow the convention here. ArrayList string. The angle bracket surround the reference type to store in our ArrayList. So if we want to store string references in our ArrayList, we put string here. And tier is the data type. It can be integer object or double object, something like that. And if we want to allocate more cells in our initial ArrayList, we can simply change the content inside the round brackets. We can set it to 20 or even larger than 20. So the original amount of the ArrayList cells will be allocated for us with the new keyword. So for now, I don't put any number in the actual parameter of the ArrayList constructor. So the default number of cells will be given to me, which is 10 cells. When we play with ArrayList, we have to understand two more concepts. Not all the cells in an ArrayList are filled up. So when we talk about the word size, we just talk about the number of filled cells in a given ArrayList. Okay, we have another important concept called capacity. It is simply the total number of cells in an ArrayList which is able to be changed according to our insertion of new data into the given ArrayList. So originally, when I have this statement, I will have 10 cells after the first element is inserted. So for now, I will have 0 cells in the given ArrayList. When will I have 10 cells? When I add the first element in the ArrayList, the capacity will be raised to 10 immediately from by Java system. So when I create the ArrayList here, there is no cells in the memory, but when I insert my first element, the default capacity will be changed to 10 accordingly. If you put 20 in the round brackets, the default capacity will become 20 after the first element is inserted. So let me do it now about the size of an ArrayList. When I use the size method of an ArrayList, what will I get now? I will get 0 because I haven't put any object into the ArrayList. That means I haven't put any new data to the ArrayList. So there is nothing inside actually. So the size, that means the number of filled cells is 0 in this case. So how can I add something to an ArrayList? Now I'm going to put some names of the fruit. I put a string whose content is apple, and I don't put the string object directly into the ArrayList. Instead, I will simply put the reference of this string object to the ArrayList. So remember, when we talk about ArrayLists, the cells don't store the objects directly. We simply store the reference to this string object. Let me put more names. Now I've put 3 string references into the fruit ArrayList. I can show you the size of it now. Now I have 3 cells being filled in the given array list whose reference variable is called fruit. I can get the content stored in a particular cell in the array list. When I use the get method with the index of the field elements in the array list, I will simply get banana. Let me see. Yes, I will get banana because the index starts with 0. So apple is simply the string object with index 0. Banana is the object with index 1, and pear is the object with index 2. To be more precise, 1 refers to the index of the string reference pointing to the string object whose content is banana. So when I print the content by means of the get method, I will get banana. When I want to add something or insert something to the given array list, I can do something like this. I want to add melon to index 1 position. That means the order now will be apple, melon, banana, and pear. So banana and pear will be pushed down by 1 cell. And I can check the size now. It should become 4. Yes, it is 4 because I now inserted another fruit into the array list. When I check the index, I will get melon. So index 1 now becomes melon instead of the original string content called banana, because the insertion will shift the original cell contents by 1 cell apart. I can get another cell which is having an index 2. So banana becomes index 2 instead of the original index value of 1. If I want to show the index of a given string object, I can have the approach in this way. By using the index of method followed by the string content as the actual parameter, I will get back the index of the word pear in my array list, which should be 3 in this case, because pear becomes the 4th element in the array list, which corresponds to index 3. Yes, I will get index 3 as the answer. If the actual parameter is not existent inside the array list, what will I get? Actually, I will get -1, so I can try something like this. Let me see the result. Yes, I will get -1 for orange because this string is not present in my given array list. When the string is not present, I will get -1 as the index coming from the index of method. Okay, how can I remove something out of the array list? I can do something like this. When I use the remove method in this way, I'm going to remove the element with index 0 in my given array list. So I'm going to remove apple. And then banana or melon or pear will be moved up by 1 cell. And the variable called fruit removed is going to store the object reference of the object that is going to be removed. So let me print the result out. Okay, apple will be removed. So apple is no longer inside the array list, but instead it is represented by the reference variable called fruit removed. I can check the size now. Yes, it becomes 3 again because the first element called apple has already been removed. If I want to remove a particular string from the array list, I can use the remove keyword in this way. In this case, I'm going to remove the string reference which is pointing to the object called banana. So I will have melon and pear only. The size would become 2. Let me see. Yes, it is 2 because both apple and banana are already removed. So the array list has only melon and pear. I can also use the set method for an array list. So when I have this pattern here, I'm going to set index 0 of my array list as having lemon. So originally my array list is having melon as index 0. But now the content of the first element will be replaced by lemon. So melon is no longer existent. How can I know that? I can print the element out. Yes, the first element becomes lemon instead of the original melon. And I can check also the second element, which should be pear. Yes, pear remains in the array list, but melon is already removed because it is set to become lemon. So the array list now has these 2 elements. Okay. And then I can tell you something about the auto-boxing issue of ArrayList. Because we know that ArrayList stores object references, when we actually put some primitives into ArrayList, Java needs to change the primitives into its corresponding object type. So let me see an example. Okay, this statement is going to create another ArrayList whose reference variable is called age, and for this reference variable, it is pointing to an ArrayList that stores integer references. Here, we use capital I to indicate the integer object type, and here I create 10 elements in the first place when I put the first elements in the array list. That means that my capacity will become 10 once I put the first element in the array list. In the old days, when we want to create an integer object, we rely on this assignment statement by using the new keyword. But starting with Java version 9, this approach is already deprecated. So we don't create an integer object explicitly. So what will I do now? If I want to store a primitive into an array list, I can simply make use of the auto-boxing property. I create an integer object first by means of auto-boxing property. So I assign 13, which is a primitive, directly into an integer object reference called an int. And then I add the integer object reference to the array list whose reference variable is called age. So I can make use of the add method to help me insert an integer object into an array list. This is one way of doing the assignment of primitives. We have another approach of inserting primitives to array lists. We can also directly put the primitives into the add method. When we do so, auto-boxing will be performed for us directly. So when we put the primitives into the brackets, it will change the primitives into an integer object, and then the integer object will be added to the array list. I can print the elements out. Yes, I will get 13 as the first element in the age array list, and I will get 15 as the second element of the array list whose reference variable is called age. Remember, index 0 means element number 1, and index 1 means the second element in the array list. I can remove an integer object which is pointing to 13, And after the removal, I will have 17 being the content of index 1 instead of the original value of 15, which was the element of index 1. And then I can get the size of the array list. It should become 2 instead of 3. Yes, it is 2 because I already removed one object out of the array list that was storing initially 3 objects. When we want to go through the whole array list, how can we do that? We have 2 ways to do so. The first way is to use an iterator. If we want to use the iterator, we have to import it beforehand. So we go to the top, and then we add one more import action. Okay, I'll add the iterator library here at the beginning of the program code. And then I can go back to the main method. Okay, now I create an iterator whose reference is called iter. And what is iter? Iter is simply the iterator for my age array list. So I will use age.iterator. So iterator is a method here, and I would put that method to my array list called age. Okay, and here that integer means that I'm going to have an iterator that gives me integer objects. Okay, so how can I traverse all the elements in the age array list by using the iterator? I can do something in this way. Okay, I can use the hasNext method pertaining to an iterator. So if the array list is still having values, it means that hasNext is correct. And then if this is correct, I will print the value coming from the age array list. Okay, so if there is a next number, I can print that next number. So let me see the result by printing it out. Yes, I can get 2 values in the age array list. Okay, so for number 15, it is the first element. So hasNext method is true. In this case, I will get the value coming from the next method. Same for 17. And after printing 17, the age array list has nothing more. So in this case, hasNext becomes false. And if it is false, the printing result would not be shown anymore. So this is the traversing technique by using the iterator. And the second technique is simply by using the for each method. Okay, this is the for each loop. I want to print out all the elements in the age array list. So I would have this format. Here, integer means the integer object data type. I is referring to the object stored in the ArrayList. Okay, and I'm going to search for the age ArrayList, and from this ArrayList I'm going to print out all the values in this ArrayList. So I will print out 15 and 17. Let me see. Yes, both 15 and 17 are printed out. That means I can traverse the ArrayList by using the for each approach. So that's the end of the video. That helps you to understand the mechanism of ArrayLists. I hope you're able to add things to an ArrayList, remove the things from an ArrayList, and even print out every single element in the ArrayList. This is the end of the video. If you have any questions about my video, feel free to leave your comments on the comment section below the video. If you like this video, please give me a like and please subscribe to my channel. Thank you for watching.